All right, unofficial advent of code, day 21. Here we go. No, oh shoot, I didn't see it. Day 21. Dirac dice. Not much to do as you descend to the bottom of the ocean. Nice game of Dirac dice. Single die, 2 pawns. Game board with a circular track containing 10 spaces marked 1 through 10 clockwise. Each player's starting space is chosen randomly. Your puzzle input. Space 1 equals stir 0.split. Okay, spaces track equals 10.times.map. On each player's turn, the player rolls the die 3 times and adds up the results. Then the player moves their pawn that many times forward around the track. That is moving clockwise on spaces in order of increasing value, wrapping it back around to 1 after 10. Score 1 equals 0. Score 2 equals 0. Value of the space their pawn stopped on. Deterministic dice, 100. Okay, after which it starts over at 1 again. Giving these starting positions. Okay, I have a feeling I'm gonna have to like iterate twice and then a million times. Okay, so it's the sum of 3 values. Die equals 1. While score is less than 1,000 and score 2 spaces equals space 1. Scores dot all. Dice rolls equals 0. 2 times do n break if scores n is greater than 1,000. Okay. Dice rolls plus equals 3. Moves equals -1. Die plus equals 1. Die equals if die moves equals 0, 3 times do. Okay, moves space n spaces n equals spaces n plus moves mod 10 scores n plus equals spaces n plus 1. Puts part 1 scores min dice rolls. Uh, 3, 7. Oh, 5, 9, 3, 2. All right, 655. Single 3-sided die. When you roll it, the universe splits into multiple copies, 1 copy for each possible outcome of the die. In this case, rolling the die always splits played the same as before, although to prevent things from getting out of hand, the game now ends when either player's score reaches at least 21. Okay. Okay, so we can keep track of universes, num universes, scores to num universes equals hash dot new h z hash dot new. Scores to num universes 0, 0 equals 1. Okay. And now we do this. Scores to consider equals 0. Yeah, I'm not going to worry too much about like backtracking. While scores to consider any next to games at score equals scores next score to consider dot pop games at score equals next score. Okay. When you roll it, the universe splits into multiple copies, one copy for each possible outcome of the die. 3.times do new scores to consider. Oh, shoot, but I still need to keep track of the spaces, which is basically 100. So I'm going to have 21 times 100 times 100. 4 million. So 3 times 3 times 3 is 9, 27. So there are 27 different totals. There's one way to get 3 counts equals roll ways to roll n. 3, there's one way. 9, there's one way. 4, there are 4 ways. No, 3 ways. 8, there are 3 ways. 5, there are 3 ways. 6 ways. So this is like 1 1 3 1 3 1 3 1 1 1 2 2 2 1 2 2 2 1. Yeah. And so then this must be 27 minus these. So 27 minus 6 minus 6 minus 3 minus 1. 8 ways. No, 7. 1 2 3. Yeah, because it's all the permutations of 1 2 3, of which there's 6 plus 2 2 2. Cool. Ways to roll n. So now scores in universes. Space 1, space 2. Universes to consider. Universes. Universes equals 1. Initial universe equals 0 0 space 1 Universes to consider equals initial universe. Universes to consider next universe. Wait, no, it's 21 times 21 times. Okay, only 44,000 possible universes. This is game states. Game states. Game states. Game states. Games at games in state. Games in state. Initial game state. While states to consider state score 1, score 2, space 1, space 2 equals state, num games in state, scores equals score 1, score 2, spaces equals two times do n ways to roll n dot each do move and num ways. Okay. Spaces and moves, scores and okay. Break if it's greater than 21. If scores n is less than 21, we keep going. Winner win count. If scores n win count n plus equals 1, else new state equals spaces equals scores 1 spaces 1. Oh shit, turn. Turn new turn. Next turn equals 1 minus turn. Next turn. New state. Games in state. New state plus equals num ways times num games in state. States to consider. Next, if num puts considering state inspect num games current games in state. Set that new. Oh, it doesn't have sample. That's a bummer. Consider new state. Turn. Wow. Puts win counts. I feel like it did something wrong. Rolling the die always splits in the universe into 3 copies. Huh. Why are there so few? Puts games in state.inspect. Num games in state. Three, 3. 1 plus 3 plus 6 plus 7 plus 6 plus 1. 27. Puts states to games in state values dot sum total active games. That seems wrong. 17. How is it 17? Puts adding new state, adding games. That is so not correct. Oh, num games in state. 1. Num ways. Okay, that's more. That's a bigger number. Huh. New space equals new space equals that, new space, new score, new state, turn equals new score, new state, 2 plus turn equals new space. $84. Scores turn. If new score So this should eventually converge. Shift. Four, 4, 3, 5, 3, 4, 1, 9. Perfect. Woohoo! Example. Okay. 35. Leaderboard for day 21. Let's see. No, not even for part 1. That was sort of close for part 1. Anyway, all right, let's go over this. Day 21. Oops. All right, day 21, Dirac dice. Let's make sure I'm pronouncing that. Paul Dirac. Hey, that's my name. Dirac. Trap. Dirac. Dirac dice. All right. Game consists of a single die, 2 pawns, and a game board with a circular track containing 10 spaces marked 1 through 10 clockwise. Each player's starting space is chosen randomly. Your puzzle input, player 1 goes first. Players take turns moving. On each player's turn, the player rolls the die 3 times and adds up the result. Then the player moves their pawn that many times forward around the track. That is, moving clockwise on spaces in order of increasing value, wrapping back around to 1 after 10. So if a player is on space 7, they roll 3, 2, 2, and 1. They would move forward 5 spaces and stop at 2. After each player moves, they increase their score by the value of the space their pawn stopped on. Scores start at 0. Game ends when a score reaches at least 1,000, and it ends immediately. So for part 1, we're using a deterministic die that first rolls a 1, and then a 2, and then a 3 up into 100, and then after 100 it returns a 1 again, and then a 2, and then a 3. So we're going to use that die. And what you're going to play once, what do you get if you multiply the score of the losing player by the number of times the die was rolled during the game? So we parse out our spaces, starting spaces, these are for the example, and initialize our scores. Here we go. These are not used. So while all the scores are less than 100, 1,000, I think we can just change this to loop. Whatever. For each player, we store our spaces and our scores in arrays of length 2, and we'll just index into them. So for each player, we roll the dice 3 more times. The number of times we're going to move is initially 0. We add up the value on the die, add 1 to the die, set it to 0 if it's greater than 100, and then do that 3 times to get number of spaces we move. We set the spaces, new space to be the old space plus the number of moves, mod 10, and then the score is the spaces plus 1, because the spaces are 0 through 9, but the actual scores are 1 through 10. And then we're just going to break if the score is greater than 1,000. So part 1, we just get the minimum value of the scores. That's the score of the losing player times how many dice rolls there are. Pretty simple. Yeah. So then for part 2, time to play the real game. We use this a Dirac die. An informational brochure explains that this is a quantum die. When you roll it, the universe splits into multiple copies, 1 copy for each possible outcome of the die. In this case, rolling the die always splits the universe into 3 copies, 1 where the outcome of the roll was 1, 1 where it was 2, and 1 where it was 3. Game is played as before, although to prevent things from getting too far out of hand, we now end when someone gets to 21. And we want to know, in all of the possible universes, how many universes the first player will win more. In all of the possible universes, how many times does player 1 win? So we're going to keep track of how many games are in different states. And it's pretty easy to represent the states. We have the score of the initial player, score of player 1, score of player 2, space of player 1, space of player 2, and then which player's turn it is, 0 or 1. And we have 1 game in the initial state. And we're basically going to go over every state, figure out how many games are in that state, figure out all the different new states it can get into, and then multiply those states by, add the number of new ways, add more states to those. So when you roll something that can be a 1, 2, or 3 times, there's only one way to get a 1. Basically, there are 27 different possibilities, but only one of those rolls a 1, or only one of those rolls a 3. One of those rolls a 9. 1, 1, 1, 1, 1, 2, 1, 2, 1, 2, 1, 1. There are 6 ways to get a 5. And then by symmetry, there are 6 ways to get a 7, 3 ways to get an 8, 1 way to get a 9. A 6 you can either get by rolling a 1, 2, and 3, and any of the 6 permutations of that, or a 2, 2, 2. So there are 7 ways to roll a 6. So we're going to keep track of how many wins each player has. So while we have any states to consider, which just starts as the initial game state, we're going to get the next game to consider, state to consider. We break up that state. We get how many games are in that state. We reset it to 0 because we're going to move all of the games in that state into a new state. We're also going to just be done if there are no games in that state, which might happen if like a state gets added to the queue multiple times. So we can do like the same indexing thing. We create our scores array and our spaces array. And the next turn will just be 1 minus the current turn. So if it's 0, 1 minus 0 is 1. If it's 1, 1 minus 1 is 0. So this switches the turn. So then we loop over all the different possible rolls. And we get the number of moves for that possibility and how many ways we can get to that possibility. So the new space is going to be the current space plus the number of moves, mod 10, and the new score is going to be the old score plus the new space plus 1. And then our new state is the same as the old state. And now we're going to update the new score and the new space. If the new score is greater than 21, greater than or equal to 21, then that was a win for that player. And so we update the win count with the number of games in that state and then the number of ways that they rolled that number. Otherwise, it wasn't a win. So we need to add, say that there are now a bunch more games in that new state. So we add number of ways to get to the number of ways for that roll times the number of games in that state. We add that to the games in the new state. And then we say like, hey, we have to consider that new state. And that's pretty much it. So then we have the win counts and we just print out the max of the win counts. And it doesn't take too long, but yeah, that's it. Yeah, that is, commit, that is December 21st, 2021. Advent code day 20.